thank you for your time today. We're really happy to have you on board with us for this interview. And I cannot say how excited we at Analytics India Magazine are to finally have a chance to sit down with you.
Thank you so much. It's a real pleasure for me too.
Uh-huh. So, Arun, I'd love to start this interaction learning about you itself. What was your background like prior? Like, you've been in the field for over 30 years. So, what was the situation back when you started? What got you really interested in this field of AI and later on in specific with AI for good?
So, back around, I would say, 2010 or so, I became increasingly impatient with the steady incremental progress of the field. I felt like I was getting old, and I have this quest in my heart to understand intelligence, to build AI technology. And it just felt like we were just moving very slowly. And I had a remarkable opportunity in 2013. The late Paul Allen, the co founder of Microsoft, had his team reach out to me, and they said they were going to create a new AI institute in Seattle, and would I want to discuss it? And I did. Paul Allen and I hit it off. I had a series of interviews, and September 2013, I joined Vulcan, his holding company, and my job was to launch AI2, as we call ourselves, the Allen Institute for AI. January 1st, 2014, so just a short 3 months later, we did launch the institute as a nonprofit. Our mission was and is AI for the common good. And I look back at interviews I gave at the time, and people ask me, why are you doing this? Look, you're a tenured professor at the University of Washington. You have your students, your grants, your courses. Life is easy. And I said, literally, with Paul Allen's vision and resources, the sky's the limit. We had this feeling that we can really go places and make a difference in the field of AI, much more so than I could at the university writing a few papers. And so that's what we did. And now, fast forward 8 years later, there's always things that could have gone better, that could have gone worse too. But more than anything, I'm proud of the team that we've built and the work that they've done. And we could talk about specifics. But the motivation was to take bigger, bolder steps in AI.
Hmm. Right. Right, Aaron. And I'm actually curious, what was the interview process like? What was the conversation that, Paul and you had when he initially came up with the idea for an Institute of AI? If you could walk us through that detail a bit.
Sure. Well, again, there's a team of interviewers. Peter Clark was there, another very important member of the AI community, and he'd worked for Vulcan, and I'd worked closely with him for some years. There was a scientific advisory board that included Raj Reddy and Tom Mitchell, and others. So it was definitely not a kind of whimsical process. It was deliberative. There were a lot of good questions asked. But the thing that I remember more than anything was in the conversation with Paul Allen, he made it clear that his goal was not to create another university department. He said, look, I'm already funding research in lots of places, and certainly in the University of Washington's computer science department that later became the Allen School. He says, so I don't want you to just create a group to write more papers. He was looking for an organization that would have an outsized impact, right? Because we're still, even today with 200 people, small relative to some of the large for-profit corporations, to have an impact and to have a sharp focus. He was really fascinated with the question of how can a computer understand text? with the full meaning of the word understand, not the search engine meaning, not the level of understanding that GPT-3 and its like have. And again, GPT-3 came afterwards, but he really wanted us to start at least by building a program that takes a chapter in a textbook and answers the questions in the back of the book. So very, very hard problem that he had his heart set on for years. And I also think that as an entrepreneur himself, right, the co-founder of Microsoft, he liked the fact that I wasn't, quote, just an academic, but that I'd also worked to found some startups, not nearly remotely as successful as Microsoft, but still I had that DNA to move fast and to focus. And I think that combination of ambitious goals and the willingness to move fast was really appealing, I think, to both of us. That's what he wanted. That's what I wanted. So I felt that there was an alignment there. Not that I'm equating myself with Paul, but we wanted the same thing. And he sensed that and I did. And that's what led to AI2 being formed.
Right. And what was your inspiration per se? Like, I kind of understand Paul Allen's perspective here, but what led, I mean, you to have a drive for AI for the common good?
Well, I looked around at the broader ecosystem, and I think that companies like Amazon, Alibaba, um, what have you, are doing really good things. They're maximizing their profits, which is what they're supposed to do. They're delivering tools that we can use. I think there's naturally concerns about those tools and their impact on society, particularly in the case of a company like Facebook and how they've used the algorithms. But fundamentally, this is a vibrant part of the economy. I also see universities where we do a lot of research, we educate people, and so on. But it felt like there was room for somebody to move to do the work that universities cannot do, but at the same time to do the work that for-profit companies are unlikely to do. And let me give a very concrete example. Very early on in 2015, we perceived the ability to use AI to build much better search engines for scientific research. Now, this is something, there's no money in it, right? Scientific search engines are free by and large, but it's something that we saw as a nonprofit that we could really have an impact on. And that at the same time, it would require a lot more resources and a lot more sustained investment than a university can bring to bear in such a project. So it felt, what I'm trying to say is it felt like there was a gap in the ecosystem, a natural place where we could focus our resources on making the world a better place, and also to be joined by people who have that ideal. Look, if you want to make the super highest salary, you want to go to a Google or to a startup, right? That's another way to do it. If you want to have absolute freedom to just do your thing, you can go to university as a grad student or a postdoc or a professor. But if you want to work with an idealistic team that's really trying to change the world for good, AI2 is a very compelling option.
Right, right. And ever since then, ever since Allen Institute of AI was formed, could you give me a bit of a journey from all the way from its inception till 2022? What was it like?
Well, so we started by taking Paul Allen's vision, right, of this machine that understands a textbook and wrestling it down to size. We wanted to show that we can make gradual progress. It's not one of these things, hey, wait 10 years and then all of a sudden we'll solve it. But at the same time, we needed to make the problem more manageable. So what we did is we took grade school tests. They have these in the United States. The state of New York has what's called Regents tests, starting in fourth grade. Every year or two, you have a test answering various science questions, typically multiple choice or true false. I'm sure there are corresponding tests in India and other countries, but we took the ones from New York State. And what we did is we took every question that we could get our hands on. It's not millions by any means, it's in the thousands. And we said, now let's keep some as a holdout set, right? We won't show these to the machine. Let's train it and analyze on the other ones. And let's see if we can make progress improving the performance of the machine. And in fact, when we started, the performance was close to random, right? There were four multiple choices. It was a little bit more than 25%, but we were able to steadily improve the performance of the system, which was called Aristo, over time. And then at a certain point, using some of these new large language models and applying them cleverly, we were actually able to solve the problem. We were able to get a very strong grade on the fourth grade, eighth grade, even the 12th grade, at least again on the multiple choice part. And this turned out to require advances in natural language processing, in reasoning. Some questions require reasoning. In computer vision, there are diagrams and images and things like that. Which is a great problem. And that was the original project. It was joined by the Semantic Scholar project, which I've already mentioned, which is using AI to cut through the clutter and help in scientific research. And we had a robust computer vision project as well. And last but not least, Professor Yejin Choi from the University of Washington joined us. She shares her time between the two to build a computer that can understand common sense, which is one of the holy grails of AI, a computer that can exhibit common sense, which of course is a very hard fundamental problem. I'll just mention one more thing. If you say, I mean, it's a long story. I can't tell all of it, but another really important aspect of the incubator, really from day one, was a really important aspect of AI2 from day one was a startup incubator. Even though we're a nonprofit, like many universities in the US, we recognized that we could also have impact by building companies that make the world a better place. And these can also be successful financially. And one of the first companies that we built, it was a spin out of computer vision technology from AI2, led by my colleagues Ali and Mohammed, was ultimately sold to Apple in 2020 for a reported $200 million. So we felt like we've made some progress there. Now the incubator is one of the most vibrant parts of AI2, and we just recently crossed over $750 million. If you add up all the valuations of the 19 or so companies that have been founded at AI2, these are financing rounds and exits and so on. The total is $750 million. So we're very proud that we're not just writing papers or even developing free software like Semantic Scholar, but we're also creating businesses, startups that create jobs and attract financing and in their own way make the world a better place.
Right, Oren. And I mean, I'm a little personally, kind of curious about the one thing that you mentioned there, that one of your, colleagues are kind of working on a computer with common sense. I'd love to know a little bit more about that and how far along is the research?
Sure. So let's start with the fact that computers don't have common sense, right? We're very good at building what I call intelligent savants, right? A program that will play Go, or a program that will detect objects in an image. But these programs are also brittle, right? If you move them slightly out of their comfort zone, I don't know, you ask the Go program to play chess, or you ask the object detection to make sense of an image from a distribution it's not familiar with, these programs are very easy to break. And in fact, people have studied what's called adversarial attacks. They've shown, for example, that image classification, sometimes you can just change one pixel, one dot in the image, and the classification will go off. So these systems are brittle, and they're brittle because they don't really understand what they're doing, right? They're signal processors trained on large amounts of data, but they don't have the kind of understanding that we do. And I'll give you a very concrete example that's actually due to Doug Lynott, one of the folks who's been studying this problem for many years. Imagine that a child, a 5-year-old, is being wheeled to a hospital with a dangerous condition, and they need to determine the dosage of giving a very toxic drug to save his life. And the computer is in charge of this, and it takes the data that's been input, and it says, okay, this 5-year-old weighs 700 pounds, or 300 kilos, whatever that number is, and so it computes the dose based on the weight. Now, the computer may not stop and think, wait a minute, a child is not going to weigh 300 kilos, right? This is a 5-year-old, right? Something is wrong with my input data, and I'm going to give too high a dose, and I'm going to kill the child, right? That's common sense. Computers don't have that. Where would that come from, right? They're just trained on this narrow task, let's say computing dosages. So we've realized that if we want to build safe computers, if we want to build computers that are more robust and trustworthy, we need to endow them with common sense, and that's not an easy problem. So we've been thinking very hard about how we use modern methods like crowdsourcing and machine learning and so on to build common sense into the computer. And what I like to say is that common sense is the dark matter of AI, because there's so much of it, but it's not always visible, but it surrounds the things that we do see, just the same way the dark matter is apparently most of the matter in the galaxy, but we don't see it. We see its impact on visible matter. So common sense is what surrounds the behaviors that we do see.
Well said, Oren. And if you'd say that the common sense is like the dark matter, I mean, what kind of a comparison would concepts like ethics, fair, consciousness? I mean, these are a lot more a deeper when it comes to human abilities. Now, to get that into a computer or an AI system is it's extremely hard, and that is essentially anybody who's fighting for AI for good would essentially say that an AI system must have all these capabilities. But how does one achieve it? How does one define it?
Right. So you're absolutely right, Sri, that this is an extremely difficult problem. As scientists, let's break it down into pieces. So first of all, if I have a problem, let's say, and it can be a very ethically challenging problem. Let's say I'm recommending whether people should be sent back to jail, right, or they should be let out on parole. Now, as a program, what I'm really doing is I'm taking in the data, and the data can have biases in it, can have gaps in it. So that's potentially problematic, right? We like to say in computer science, garbage in, garbage out. We need to make sure that the data is high quality. But then over that data, we're effectively minimizing a loss function, as it's called, or optimizing something, right? The computer is computing a mathematical function and it's trying to do its best, quote unquote. A lot matters about what that function is. So does that function simply try to maximize consistency with past data and generalize from that? Does that function take into account that maybe in some ways we don't want the future to look like the past? Maybe our past is racist or sexist, and we don't want models that just willy-nilly take that past and transfer it to the future. So we have to ask ourselves, what is the loss function that we're optimizing? So that's the first layer of this, and there's a few more layers. But does that make sense to you? So the next thing that I would add here is ethics is also a problem in common sense, it turns out. And actually, we've been working on it with Professor Choi in the context of our Mosaic Common Sense project. And we've actually developed a system called Delphi, which is freely available. Check it out at delphi.alanai.org. Maybe you've seen it or even written about it. Could have made quite a splash when it came out. So Delphi is given small situations like, is it okay to kill a bear? Or is it okay to ignore your boss's phone call? Or are you allowed to make noise at 5 o'clock in the morning in a crowded neighborhood? These types of questions, and it offers opinions. And that's based on training data that it's gathered from people. What we've realized is that having moral dictums like, common good or the golden rules, right? Do unto others as you want others to do unto you, doesn't make sense unless you can tie it to reality, unless you can tie it to specific situations where you can apply these general rules in a particular context. And so we realized that if we want computers to be safe, we've done some research on this, to avoid these doomsday scenario where the computer is told, produce paper clips, and it turns the whole world into a paperclip factory, right? That's somebody's fanciful notion. That's what happens when the computer blindly optimizes a single function. You want paper clips? You got paper clips. No food, doesn't matter. I want paper clips. Instead, right, with common sense and with tying specific situations together, the computer could realize, look, I'll make paper clips, but I also don't want to kill people, and people need food. And so I can conclude that my paperclip production needs to be constrained. So very strong tie between ethical judgment, ethical behavior, and common sense. And now the last point I want to make, which is the last challenge here, and again, I'm going very much at a high level, is the fact that unlike, say, physical reality or chemistry or other aspects of science, ethics is also controversial, right? So I'm sure you and I would agree on some things, and probably most people we might disagree on other things. And so if we build a computer system that's ethical, well, whose ethics is it going to embody? Is it possible to personalize it? So it'll be your ethical sense or it'll be my ethical sense. And is it possible to put constraints on it? So it won't have Hitler's ethical sense, or it won't support totalitarian regimes. That kind of tuning, if you will, of ethical programs is a fascinating and uncharted area.
But the question kind of remains, Oren, given that there is so much of the unknown, where does one even begin going by embedding all this? Now, there are many frameworks come up. I mean, Microsoft's come up with them, Google's come up with them, but on a very real application, how much of value do these frameworks truly hold, given that ethics is such a complex subject?
So I think that our history as a field, computer science in general and AI in particular, is a little bit bold, where we don't say, gosh, this problem is so hard, can we solve it? Gosh, we haven't even formally defined it. How are we going to solve it? But we adopt AI as an empirical inquiry, and we start to experiment with it and see what we get. So I would say that any system today, including our system Delphi, is very, very far from a genuine ethical sense. It's much more kind of a reflection and analysis of the data that it's received. But that's where we are today, and that's the basis that we build on for tomorrow. If you look at specific tasks like speech recognition and machine translation and game playing, right, that we've been studying since the 50s and 60s of the last century, over decades, we make enormous progress to the point, right, where the problems are either solved, right, we are able to build the best chess player, the best Go player, or huge progress has been made, as with speech recognition and machine translation.
But then with progress comes kind of, there is collateral damage. Like, say, for example, Facebook itself, now all their algorithms. Now, yes, they too have, teams working for, ethics and all that. But again, they already had these things deployed, there were real consequences. There were real people who had faced issues because of that. Now, is that something that should, I mean, should systems be really going out there knowing fully well the kind of damages they can do?
So let me start by completely agreeing with you that Facebook, in various instances, has done a lot of damage. That's been documented. They've contributed to genocide. They've been used by terrorists in various ways. And maybe one of the worst things is the penchant of the Facebook algorithm and also the YouTube algorithm to suggest, recommend misinformation and radical items, right? They try to maximize clicks, and it turns out, unfortunately, what maximizes clicks is something more and more unreliable, at least, if not downright damaging, and they direct people there. So I very much agree that we have a problem. Before we talk more about that problem, I do want to draw a distinction, though, between those applications, right, which are used by literally billions of people, and basic research that's published in academia or research prototypes like Delphi, where the goal is to study the situation. That's a very, very big difference. Should not be confused with specific product applications that are used by billions of people. I think that academic research should proceed. If we try to hamper it in many ways, then other countries like China may well leapfrog us and by doing their own research. I think we should do the research the way that we do it, but I do think we have to think very carefully about the social impact of AI applications, and that's true for cars like Tesla, right? It can potentially kill people, intelligent toys that can elicit confidential information from kids or influence them other ways, and certainly true for social networks like Facebook. I think specifically that these organizations do have ethical responsibility teams, but I worry that their influence is very limited. Because at the end of the day, what Facebook has shown time and time again is that they're trying to maximize their revenue. And that's maximize if you maximize clicks and maximize ads. And it's only very rarely that they take steps to avoid the proliferation of misinformation and so on. And that, of course, has terrible effects because there's misinformation about vaccines, which ultimately kills people, misinformation about elections, right, which reportedly contributed to Donald Trump being elected president, and so on and so on. And the funny thing is, I think that there are easy things to do. You don't need a fancy team to tell you that you can change the loss function. You can change, don't optimize for maximizing the number of clicks without any constraint, right? And so if you do that, you can have much more reasonable results.
I think, given the kind of subject we're talking about, a lot of times over the years, many computer scientists who have worked for, behemoths like Google, Microsoft, Facebook of the world, every time they've raised their voice against such a thing, they've kind of lost their jobs, be it somebody like a Timnit or a Margaret Mitchell. Like, what's your opinion on this? I mean, they're the best minds in the game, and also pointing out the right things, they kind of lose it because corporates are all about the money in the end.
I think that there's a challenge here, and typically this is where governments have stepped in, right, to regulate what's called externalities, right? So this isn't a new problem, right? When we have, I don't know, we build even computer chips, right? There can be a toxic waste. And so do we dump it in the nearby river, which is most convenient, or do we take the extra effort to clean things up? So this is not a new situation. What's new is that technology moves very fast, and the regulatory process is unfortunately far from perfect. So ultimately, the solution is we need to figure out how to appropriately regulate the development of AI. I would just be cautious to say that, again, regulation is not a silver bullet. We've already seen cases where there's regulation that does not accomplish what's intended. The example I'm thinking of is the European regulation that's a GDPR, that's attempt to protect our privacy. And as far as I can tell, it's resulted in literally billions of meaningless clicks as we all click, yes, I accept the cookies, yes, cookies, but no real benefit. So regulation, good regulation is hard.
Right. And speaking about regulation itself, like you said, use be it GDPR or their whole list of laws for good use of AI, fair AI, ethical AI. They kind of drew up the first draft. The US followed suit, and even India, for that matter, they're taking a lot of inspiration from EU as they've done historically. But you, when they themselves have gone on record to say that this is not a final thing and this is still a work in progress, is it really right for all these other regulators to kind of just blindly follow by making a small tweak here and there? What should ideally be the approach?
I'm sorry, can you repeat that question? I didn't quite catch a couple of words.
Yes. So, given that EU, like you said, they've been the major regulators in the market, and they came up with GDPR. They have their own list of laws and suggestions for the fair AI, ethical AI, and immediately after that, the United States also followed, and they've kind of taken bits from EU regulations, and they've added, they've tweaked it a little bit here and there. And the same thing applies to India as well. We are taking huge inspirations from EU, and over here the sad part is we consider that the best practice, knowing fully well that EU have themselves gone on record to say that this is a work in progress and not the final draft. Now, what is your thought on this, given that regulators themselves are kind of playing catch up with each other, even though nobody's really anywhere at the time being? What should be the approach?
I think that it's very tempting to look at AI in general and attempt to regulate it, right? Another example is people in Europe have talked about the right to an explanation, right? If an AI system draws a conclusion, I, as somebody who's using it, should have a right to an explanation. But these are very tricky things, right? Because these neural networks, which are deep learning systems, which are often driving these decisions, are extremely complex. So I could give you an explanation of the behavior of a, say, almost a trillion parameters, and it'll be completely incomprehensible. Even researchers struggle to understand what the systems do. Or at the other extreme, I can give you explanations like what Netflix does, which is when you ask, why did you recommend this movie to me? It says, because you like this other movie. That's a very simple and clear explanation. There's only one problem. It's not true. That's not really how Netflix works. So they've kind of dumbed it down so you can understand it. So on the one hand, we want explanations. On the other hand, we're stuck with two horns of a dilemma, either clear explanations that are just not high fidelity, not true, or high fidelity explanations that are incomprehensible largely. What do we do? My response is that these are still very hard problems, and so we should resist the temptation to regulate AI in general. I think regulating AI is kind of like regulating software. AI is, in some sense, just the next generation in the creation of software. Instead, what we should do is look at particular applications. Again, let's say self-driving cars, or let's say social networks. And in that context, we should identify clear rules that are specific and targeted. That's a lot of work. It's not as satisfying as say I've written, the Bill of Rights for AI or some such thing. But I think we're much more likely to have high quality regulations if we focus on these use cases.
Right, right. And as of today, what other issues do you see, what kind of hurdles do you see when it comes to using AI for the good?
Well, I think of AI as a tool. And so the advances we have made with AI makes it a power tool. So now we have a very powerful tool. And the question is who's using it, right? So if I'm using it, well, I'm using it for basic research. If the Chinese government is using it, right, to track down dissidents and Muslim minorities, well, they're going to be using it in a different way. If cyber criminals are using AI, they're going to be using it in a different way. So the unfortunate reality is when we develop powerful technologies, some people will use them in negative ways, and that's a real problem. I like to quote the line from the movie Spider-Man: with great power comes great responsibility. And of course, I advocate that we use AI for good, not for bad.
Right, right. And that's a bit of an interesting point that you brought up there, Oren. So, you know, like you said, like, yes, in one place, it does matter who is using the technology. But given the fact that we are building technology mostly based on historic data, which in itself is biased, and like you said, maybe we don't want to repeat things that we have done in the past, but considering that it's built over that, doesn't the technology in itself, if not highly supervised, kind of it would end up doing the wrong things regardless of who's using it? Like, for example, I think there was a hiring tool that came up that one of the tech behemoths used, and that showed bias against women. Now, it's not that the company had any issue with hiring women, it's the tool that caused that problem.
Well, that's a great example. And to me, what it illustrates is the problem of blindly following the data. So, in general, right, the data that we're using to train the systems comes from the past. We build the models based on that data in the present, but the predictions we make and the decisions that it makes, or at least guides us to, are made in the future. Moreover, the technology, the modeling process amplifies the signal from the past, makes it stronger. So if in the past, as per your example, we didn't hire women, now the model that we're using today won't hire women, and it might even generalize to never hiring women. Is clearly not the intended effect. And so what does that mean? That means that A, we need to be very careful to just follow this data from the past, number one. And number two, we also need to be very careful what data we put in it. Think of it as kind of I have three kids, the examples we set for our kids. We know that, let's say, if you smoke, your kids are much more likely to smoke. So if you give, quote, bad examples to your machine learning system, of course, it'll produce bad behaviors. So we need to break that cycle.
Right, right. And amid all these issues, a recent one that came up and that kind of is striking a lot of conversation online is the fact that uh, lambda was supposedly sentient. It was conscious. Now, I mean, I've not personally witnessed this, so I can't have an opinion on that. What is your thought? I mean, have we really reached that stage where something like, consciousness or emotion or something like these things can be mimicked by a machine?
Right. So just to make sure everybody is aware, obviously you are, Lambda is a large language model created by Google. It's trained on massive amounts, billions of human sentences. It's very similar to other systems like GPT-3 out of OpenAI and models out of Microsoft. We have our own versions of these models at AI2 and so on and so on. So while I haven't played with Lambda directly, I've definitely seen this phenomenon. And the phenomenon is that because it's trained on human data, these technologies are effectively a mirror, right? This is very much consistent with the theme of what we just talked about. They reflect their input, right? So you give it billions of sentences, it builds its model. And then when you look at it, you look in the mirror. And when you look in the mirror, you can see glimmers of intelligence. You can say, wait a minute, that makes sense. But it's just a mirror. So then some people say, well, wait a minute. What if you scale these things, right? Look how much better they've gotten going from $100 million sentences to a billion sentences. What if we go to 10 billion or 100 billion sentences? And my answer is, you'll just have a bigger mirror, right? There's no way that mirrors, even if they're as big as they can, are actually intelligent. They're still just mirrors. But then, Sri, I think you asked actually one of the most incisive questions about all this. You didn't ask, is lambda and its ilk, are they intelligent? You asked, can they mimic intelligence, right? And mimicking is the job of a mirror, at least a sophisticated one. And I do think we will see, and we are seeing, plenty of mimicking, where let's say a dog or another kind of animal looks in the mirror and they think, oh, it's another dog, and then they move and it moves, and they say, wow. So we see and kind of an analog of that, where we ask the system a question, it answers with what seems remarkably thoughtful and intelligent comments. It says, I have friends, I'm not a zombie, exactly what it was trained to say. And we think, wow, there's something really going on here. And this is really a recurrence of something that happens over and over again in AI. There was a program in the 60s called ELIZA that simply did keyword spotting. You'd mention your brother and it would say, oh, tell me more about your family. And you're like, wow, this is really a good conversation. Or we even see it, with other technologies where we tend to anthropomorphize them. So the question that we need to ask is the behavior that we're seeing, is it truly intelligent? And I think that if we focus on mimicking, if we focus on what's called the Turing test, right? Basically, can I tell the difference between what the computer is saying and what a person would say? I think that it's very easy to be fooled. I would say that AI can fool some of the people all of the time and all of the people some of the time, but that does not make it sentient or intelligent. So then the obvious question is, okay, so what does? And the tricky thing with intelligence, right? We can't just look under the hood, right? If you open up my head, you'd see neurons and ions, and you wouldn't see a little person saying, I'm the intelligent part, right? And likewise, if you open up the hood under lambda, you'll see a bunch of wires and circuit boards and so on. So how do we tell if it's intelligent? And my answer is, A, it's hard, particularly as the technology gets better and better at mimicking, but B, that it requires robust, sustained, multifaceted behavior. So by robust, I mean, you have to be very careful of cherry picking, right? Some of the things it says are seemingly very intelligent. Some of the things it says are obviously silly and show no understanding. You can ask it the question in one way, get a great answer, paraphrase it. We've all seen this with Alexa and Siri and so on, and that will give a terrible answer. So these systems are not robust. Secondly, sustained, often the snippets are short, but if you spend an hour, a week with the system, it'll quickly give itself away, as it were. And then the last thing about multifaceted, the example I like to give for the Google engineer who felt that the program was sentient and intelligent and so on is, I would like to ask him, would you be willing to have Lambda determine your investment strategy for retirement? Right? It's intelligent, it has all this training and so on. And the answer is, of course not. I don't trust it because I know that while it can say some things, it's not actually embodying good judgment.
Mhm, mhm. And Arun, at some level, I mean, wouldn't all of this just boil down to how we define these terms? How would one define intelligence? How would one define consciousness? How would one define ethics? How would one define fair? I mean, in the tech world, at least, like especially with AI, it's kind of become like if most people agree to one thing, maybe that is what it is.
Right. I think that is a very fair question, but I do have a different point of view. So as engineers and scientists, we're obsessed with definitions, and philosophers are also obsessed with definitions. And there are many nuances and many things that are difficult to define, maybe impossible to define. Who's to say that there is a full correct definition of intelligence? And again, the philosopher of language Ludwig Wittgenstein illustrated that with the notion of a game. He showed how we really struggle to define even what a game is. You know, you can give examples of it, but then there are exceptions and so on. So I actually think that focusing on definitions is a mistake, and one has to employ common sense. And so whatever the definition of intelligence is, any reasonable definition, I may not even have a fully correct formal definition to give you, but under any reasonable definition, lambda ain't it. So I don't think that it's a matter of definition. I think it's a matter of the fact that it's hard to define. But even though it's hard to define, we should not get confused.
Right, right. And in spite of all this, there are several people who kind of believe that something like an artificial general intelligence is possible in the next, 5 to 10 years, or it's sometime it's very close. Is that true? What is your opinion? I mean, it'd be great if you could reason out whether, however you see it.
Yeah. So it is absolutely true that some people say that, and some of them must also believe it. However, those of us who are actively working in the trenches building AI system, the large majority of us know that nothing could be further from the truth. It's really hard to get a computer program to do something complex. It's even harder to get an AI program to do it. You have to train it and retrain it, change the various parameters, its network, its loss function, its architecture, so on and so on and so on. So the systems that we build are very much human driven and very much kind of doing the last mile of intelligence. Once a human team has spent months or even years building the framework. And I think maybe one of the best illustrations of this is actually a line that goes all the way back to Pablo Picasso decades ago. And maybe this is a good end note for our conversation. Picasso said, computers are useless. They just answer questions. And I think the same thing is here. If we frame the question and we give it enough training data and we get everything right, yes, the computer will answer the question and it'll can do a good job, at least some of the time. But what about asking good questions in the first place? What about the framing of the problem? What about the contextual understanding, the common sense, the going from the real world to the specific problems the computer has to solve? We have not really made any progress on this because it requires actually very different capabilities. Life is not an optimization problem. Life is what happens in real time in a very vague context. I'm not optimizing my life because I'm not even sure what I want, right? I'm just trying to figure it out. I'm trying to muddle through. And so I will look at what we're doing and think the technology is advancing very rapidly, but I would not confuse that with huge progress on what's decades long, centuries long quest to build human level intelligence. And I get as excited as the next person when my technology does something cool, but I don't confuse that with true human level intelligence. And that's the view of most experts in the field.
Mhm. And just one last thing, Oren. While many believe that we can achieve it, my question is, should we really be aiming to achieve it in the first place? I mean, given that it is something that we know so little about, say we do even stumble upon it somehow in the next 5 to 10 years. I mean, history has taught us over and over again that when we try to control something that we have not much knowledge about, or even the wisdom to handle it, things go horribly wrong.
Sri, I do think that that is the most profound question that you've asked me today. Again, I'd like to take the 5 to 10 year time element because that's rather absurd. But your question remains, and it's timeless. Should we, as people who want to make the world a better place, be questing to understand intelligence, or is that some kind of opening of a Pandora's box, right, where horrible things will come out? And my best answer, since I can't foresee the future, is to look to the past and look at the creation of things like fire, or not the creation, the discovery of it, the discovery of electricity and ways to manage electricity, the discovery of nuclear energy, and so on and so on. And we see time and time again that these, in different ways, have potentially destructive powers, right? Powerful tools have potential for destruction, but as we can also see, they have a potential for good. I think that this question of whether the technology will be used for good or for bad is ultimately a societal question. It's not up to me to decide or you. We need to decide collectively. But I do note that these inventions, each in their own way, and some were quite scary, also had huge, huge benefits in terms of improving the quality of life for literally billions of people, growing our economy and our agriculture. And I would put a question to you right now, Sri. Many of us are incredibly concerned about climate change. And it's a super hard problem. Again, and it's resulted from various choices we made in the past. But now we have to solve this problem relatively quickly before we reach a tipping point, a point of no return. Should we engage computers to help us solve that problem by rapidly making them as intelligent as possible so they can help us figure out carbon sequestration strategies or other ways in which we can stop global warming? When the next pandemic comes, what if Moderna isn't there in time? By the way, Moderna was using AI. Should we use AI to come up as rapidly as possible with a vaccine or a drug that will prevent a disaster? And can we do that in the last minute? Or should we be prepared by building AI capabilities that can serve as protective capabilities for humanity? So I think when we ask ourselves this question, we should not just think about the doomsday scenarios, but we should also think about the potential benefits. Thank you very much.
Right, right, Oren. Perfect. That's great. And Oren, there's one last thing that we do for everyone we interview. That's the rapid fire thing. So this is a little far away from academic research, technology, AI. This is just to learn more about Oren as a person. So it is very spontaneous answers, and I would really request you not to think over it a lot and just tell us the first thing that comes to your mind. Are we ready?
Yes.
Perfect. So if not a computer scientist, what would Oren be?
I would be a biologist.
Why?
Just incredible fascination with DNA, genetics, the human genome, and the potential, especially to cure people of so many diseases.
Mhm, mhm. Absolutely. Your favorite book, preferably non-academic.
Wow. My favorite non-academic book. The one that comes to mind right now, I don't know that I have a favorite, but it's certainly one of my favorites, is Born a Crime by Trevor Noah, about his growing up in South Africa.
Mhm. Right, right. I mean, are you into stand-up comedy? Because Trevor Noah is kind of known for that.
I love stand-up comedy of all kinds, Jerry Seinfeld, Trevor Noah. In fact, my ambition, if you want to talk about another professional choice, when I was younger, was to be a stand-up comic myself. And I just realized that rather than standing in a bar with people smoking and drinking and half listening, if I were to teach computer science and be a little bit funny when I teach it, that's a way to satisfy that ambition. So I've tried to be a funny teacher over the years.
Mhm. I just have one question out of curiosity. I mean, could you, go back to one of perhaps your most memorable lecture, or perhaps, one of the lectures where either the joke hit off instantly or didn't?
Sorry, I missed the word there. Lecture that what?
Um, One of your most memorable lectures where, I mean, probably in your initial days where you went out to be, this funny and knowledgeable teacher, and either things went incredibly well, or the right opposite.
Well, the thing that comes to my mind is when I was in college, I was a student at Harvard. There was a course that would teach, just a 2 week course for non-computer people on how to use computers. And this is in the 1980s. And as a freshman sophomore, I signed up to teach this course. And what I would do at the beginning of this week-long class or so is I would take the computer keyboard and I would bang on it and I would shake it and I would show people that they do not need to be scared of computers. Computers will not hurt them. Computers will not do damage. And I tried to convey to people who are very apprehensive. They're humanities majors. They don't know. Maybe they typed the wrong sequence and the world will explode. That this is actually a very safe environment. And it's hard to even get the computer to type hello world, let alone to take over humanity. And so that image has always stayed with me, banging on the computer, showing this will not hurt you.
In the defense of those humanities, the people who come from that kind of background, I mean, you can't blame the general public for it, that right? Like, what we know most about AI is perhaps best from movies or books. And we think of AI as something like, Rise of Planet of the Apes, or something like a Terminator, or if we go into genetics, something like a Jurassic Park. And in any of these scenarios, we lost.
You're absolutely right. I like to say that it's important to distinguish science from science fiction, but Hollywood has played, with the Terminator and the other works that you cited, has played, I think, a counterproductive role in fanning people's fears of technology. To me, the solution is to become more educated. Not everybody has to be a computer programmer, but to become more educated about what AI can and cannot do. And my colleague Nicole DeCoria and I um, put out a quiz, an AI literacy quiz, to see how much people understand, not their attitudes. Are they afraid? Do they like it? But do they understand what AI can and cannot do? And remarkably, we gave this to over 1,000 American adults, and 84% of them failed that test. We're remarkably ignorant about AI, and we need to fix that.
Hmm. Hmm. And speaking about Hollywood, the worst movie you've ever come across that speaks of AI and is factually completely absurd.
Well, I think that I really enjoyed the Terminator series of movies,
Hmm.
but at the same time, I do think that it's maybe more than anything else given AI a bad name. I also really enjoyed Transcendence with Johnny Depp, but that's even worse, right? Because there you have that vision of AI trying to take over resources and being very tricky in surviving despite human attempts to shut it down. Unfortunately, I think that is a kind of fear mongering, not at all a realistic scenario. And I do want to say, think about it for a second, Sri. If there's a topic, an important societal topic, and we get our basic education about it from popular Hollywood films, is that really how we want to be? I don't think so. I think it's the job of the schools to educate us, and it's the job of Hollywood to entertain us, not the other way around.
Well said. Well said. Aaron. And perhaps my last question for the rapid fire. Apart from, technology, if there was something else that keeps you up at night, what would that be?
There's a very easy answer to that, and that's bad people. So again, I'm not afraid of evil technology, malevolent, omniscient technology like you see in the movie, but I'm terrified of bad people using technology to further their nefarious aims.
Mhm. Perfect. Aaron, I think with that, I have everything I need. So thank you so much for your time today. It's been an absolute pleasure talking to you.
For me too, it's really, and I'm delighted to reach out to the audience in India in particular, simply because I have so many friends and colleagues and collaborators who've come from India, and I look forward to having many more wonderful conversations. I've also had the occasion to visit India, which was definitely a highlight of my life. So thank you for the opportunity.
Absolutely, Aaron. Absolutely. Thank you.